Kia ora koutou, welcome to this video on covalent networks. So what are covalent networks? Well, covalent networks contain non-metals, just like molecules. So what would be the difference between molecules and a covalent network then? We'll have a look at two examples. So here we've got the example of a molecule. This is carbon dioxide. We know it's a molecule because it contains non-metals. Carbon and oxygen are both non-metals. And this has a defined amount of atoms in it. So we've got one carbon and two oxygen atoms, and that will always be the case for carbon dioxide. For a covalent network, we still have, the key word is covalent, we still have those covalent bonds, and we know covalent bonds occur between non-metal atoms. So covalent networks must contain non-metal atoms, but the network kind of gives it away that it's not a discrete particle like a molecule is. So covalent networks are networks of atoms that are all covalently bonded together, and there's no definitive end to the structure. So this is an example of what we would call a 1D covalent network. We will look into this more in the organics topic for the 1D covalent networks. It's just a convenient description of covalent networks for the moment. But we've got these 5 carbon atoms, but what I'm trying to indicate here with these dots is that this can continue on for an undefined length. So there could be 100, 200, or 1,000 carbon atoms, each bonded to 2 of these hydrogen atoms, except for the final carbon atoms that would be bonded to 3 hydrogen atoms. So those are the key differences between covalent networks and molecules. So what types of covalent networks are there? Well, there's the one that we've just looked at, the what's called polyethylene. We've got the carbon atoms in a long chain. These are called 1D covalent networks because they just go in the one dimension. The next ones we've got 2D covalent networks. So for example, graphite. Graphite is the only 2D covalent network that will be tested on. And graphite is made of carbon atoms that are, each carbon atom is bonded to 3 other carbon atoms, and they are in a layer, in a sheet like that. So we call this 2D because it goes, each layer has some length to it. So it's like a sheet of paper you could think of. And we will look at the properties of graphite, which is explained by the structure and bonding of the substance. And then the last one we have is 3D covalent networks, which we can have diamond as an example. The other example that we can have is silicon dioxide, SiO2. So these are all of the covalent networks that we will need to know, except for the 1D covalent networks. Actually, we don't get tested on that. That's just more of a conceptual idea. So we've got 2D covalent networks, which are graphite. Graphite is the only one that's ever come up, and 3D covalent networks, which will be either diamond or silicon dioxide, and we will need to learn how to explain the properties of these two substances, two types of substances. So in the next videos, we'll go over graphite in one video, and then diamond and silicon dioxide in the next video. Thanks very much for watching. Like and subscribe for more Chemistry 2.4 videos. See you next time.